Hello class, this is a video introducing the concept of congruency. In mathematics, expressions are equal if they are of the same value. Two expressions, or figures or shapes, are congruent if they are equal and have the same conceptual meaning. I'll go through a few examples of what this means, about this conceptual meaning. So here's my first example to you. We have 4 plus 2 and 3 times 2. As you can see, 4 plus 2 is 6 and 3 times 2 is also 6. But if we go deeper and think about the concept of what 4 plus 2 means, 4 plus 2 is 4 objects plus 2 objects. So one group of 4 and one group of 2. We get 6 things in total. 3 times 2 is 3 groups. So 1, 2, 3. These are my groups. And each group contains 2 objects. 2, 2, 2. So we can say that 4 plus 2 is equal to 3 times 2. Because they're both equal to 6, so that they are the same value, but they are not congruent because the concept of what it means is not the same. So these are equal, but not congruent. Here's another one. 5 objects, so 5 plus 5 is 5 objects plus 5 objects. That's 10 objects in total. And 20 divided by 2 is equal to 10. So these are equal to 10. So 5 plus 5 is 10. 20 divided by 2 is also 10. But the concept behind it is we have a group of 5 plus a group of 5. And this one we have 20 things in total. And we're going to halve it as equally as possible. And we get 10. So each group here is 10. So these are equal but not congruent. Now here's an example that is equal and congruent. So 5 plus 5 is 10, and 2 times 5 is also equal to 10. But the concept of multiplication is 2 groups of 5 objects each. So we can have one group of 5 and another group of 5. So in this instance, 5 plus 5 is equal to 2 times 5. But since the concept is also the same, they are also congruent. So this example here is equal and congruent. I want you to pay close attention that this symbol that we have here, 3 horizontal lines, is used to show the meaning of congruency. And I hope that you've seen from this that if two expressions are congruent, they are also equal. However, just because they're equal, it doesn't mean that they are always congruent. Let me repeat that. If they are congruent, they have to be equal. But if they are equal, it doesn't have to be congruent. Okay, so let's move on. Now, in this topic, we're going to look mainly at congruency in shapes and geometry. So, 2 or more shapes are congruent to another if one shape can be, in simple terms, we can say that they are perfectly overlapped on each other. So we have 2 triangles here, triangle ABC and triangle XYZ. If I were to, well, you can imagine it, if I can pick it up, rotate it, and perfectly line it up. As you can see, these are perfectly lining up. Therefore, these 2 shapes are congruent. So triangle ABC is congruent to triangle XYZ. Here's another example here. I have 2 triangles, DEF and DGF, and DGF. And as you can see, I could take this triangle, I could pick it up and flip it so that it overlaps perfectly like so. So it'd be like this, perfectly overlapped on top. Let me just, whoop. It can also be done with other shapes, doesn't necessarily have to be triangles. Here we have rectangles. In this one we have rectangle PQRS is congruent to the rectangle HIJK. And I'm sure you can imagine it, but I could pick it up, overlap it, and place it right on top. So in this topic, we will learn how to prove two shapes are congruent using the minimum amount of information. So this is still true that congruent things or expressions need to have the same conceptual meaning as shown here. But we're going to be focusing mainly on shapes. Okay, so they are the exact same shape if they have the same lengths, the same angles, and the same everything. So we can perfectly overlap it on top of each other. So I hope that gave you a quick introduction to congruency. I hope to see you in the next video. Best of luck.